What I've told you so far is about how we can find equilibrium. Right? We talked about what supply curves are, what demand curves are, and what happens when they come together. We can get a prediction of what our equilibrium quantity and price is, which is great. Also completely worthless. Not going to do anything with that. You can't do anything with it. How could you possibly apply this to the real world? Right? What did we learn how to do? We learned how to take a supply curve and take a demand curve and solve them together to find the equilibrium. But we can't see supply and demand curves, right? The relationships about, what if the price went up? What if the price went down? What would happen to quantity supplied and quantity demanded? So we don't actually know what they are. So how can we possibly use them to find equilibrium prices and quantities in the real world? You can't. You can't actually do that. But it's still worthwhile. I'll tell you why. Because even though we can't really figure out what the supply and demand curves are without first knowing what the equilibrium price and quantities are, right? How do we figure out supply and demand in the real world with data and stuff like that? Well, we observe the prices and quantities first, and then we work backwards, which means that it's not that useful to try to figure out what the equilibrium is, because you need to already know what it is before you can figure out the supply and demand curves in the first place. So why are we bothering with all the supply and demand stuff? Well, because it turns out to still be really useful once you stop making these curves stand still and you start moving them around. That's where the real value in the supply and demand stuff is. It's not in just writing down the supply and demand curve and solving them. It is in thinking, what's going to happen when these curves start moving, right? What are the dynamic elements of this model? So that's what we're going to start talking about. So we got to figure out, how does change over time work its way into supply and demand? Right? So we got to figure out what's going to change the demand curve. I sort of wrote down an equation for demand curve. What's going to move it around in real world terms? What are the real world changes that will actually cause demand to move around? Same thing with supply. What are the real world changes that will translate into this curve shifting, moving, waving around? And when those changes happen, what's going to happen to the market? Right? This is the real power. That's why we bothered to learn about all this equilibrium stuff, supply and demand, because we want to know about change. So we're going to work this out on the board with some examples. And it turns out that this all boils down to 4 basic things that are pretty easy to work out graphically. So I'm going to start with just a regular old supply and demand curve. We already have that. And I'm going to shift one of the curves in one direction. And we're going to ask ourselves, the real question we want to ask is, what's going to happen to that equilibrium price and quantity? Is it going to go up? Is it going to go down? Right? Is price going to go up? Is price going to go down? And why is that going to be useful? Because that's going to tell us, it's going to answer one of the questions that we wanted to know. What changes prices? What's going on with prices? If we can translate a real world thing into a shift in one of those curves, then we're going to be able to predict what that real world thing is going to do to both prices and quantities. Okay. So let's just start with the basic version of it. Let's forget the real world for a second. Let's just see what's going to happen on the graph. So we're going to shift each of these curves in one direction, in each direction, one at a time. Now they're going to shift not up and down, but right and left. Why right and left, not up and down? Because, well, what's going on? You say at a given price, what's the quantity supplied or demanded, right? What does it mean to say that, let's say, supply went up? Well, it doesn't mean that the price went up so people are making more. We already sort of captured that in the supply curve, right? What it's saying is that if the price stayed the exact same, people would want to make more, right? Let's give an example. Like, let's say that you're talking about fast food chicken, right? And let's say that the government comes on tour and says, hey, you know what? Hamburgers are banned, right? Well, suddenly McDonald's is going to be like, we better start making a lot of chicken, right? So even if the price of chicken had stayed the same, people would be wanting to make more chicken, right? That'd be a shift in supply. So the question you want to keep in your mind is, even if the price didn't change, would people want to change their behavior? If the answer to that is yes, then one of these curves is going to shift. If the answer is no, then the curves are not going to shift. All right, so let's put a shift on here to have more or less quantity at the same price, so left or right shift. If you're thinking, why don't we just swap the axes? Good question. They figured this out 100 years ago, and they just sort of got it wrong, and we're stuck with it. So let's take a supply shift to the right. We want to mark this, we'll prime. That's how economists say this is the new one. We shifted from this one to this one. This is increase in supply. So at the same price, people want to make more of this thing. So the question we want to ask is, what's going to happen to equilibrium price and equilibrium quantity? It's going to turn out to be very easy to figure out, because all we got to do is look for the equilibrium price and quantity. This is the old one. And now we just look for the new equilibrium price and quantity and see how they're different. Where's the new one? Well, here's demand, that hasn't changed. Here's the new supply, we just look where those intersect. Here's P prime and Q prime. That's shift number one. Supply goes up, what's going to happen? Well, we see that price goes down and quantity goes up. You can think about whether this makes any sort of sense. If people want to sell you more of a thing, well, they're probably going to be willing to accept a lower price because they really just want to sell it to you, right? So even if you're paying them less, they'll still do it. And the quantity is going to go up because they want to sell it to you. So they're going to sell you more stuff because that's what they're trying to do. So supply goes up, we see a downward shift in price, we see an upward shift in quantity. Any guesses if we have a decrease in supply? There's our old equilibrium. First of all, where am I going to draw my new supply curve? To the left, yeah. So move this over here. Here's our S prime. Here's our new equilibrium. The exact same thing, is just in reverse, right? So if supply goes down, you get an increase in price and a drop in quantity. I really don't want to sell you this thing anymore, so I'm going to sell you less of it. Quantity goes down, and you're going to have to pay me more to get me to do it. So price goes up. All right, we're halfway through. Let's do demand. Let's do an increase in demand. We got supply, we got demand. Here's our old equilibrium, V star, Q star. And we're going to make a demand increase, which again is going to be a rightward shift. There our new demand curve, D prime. And here's our new equilibrium price, P prime, and quantity, Q prime. So at a given price, I want to buy more of this thing. So I'm going to buy more of it because I want to buy more of it. And I'm willing to pay you more to do it because I really want this thing more now. So demand goes up. We're going to see an increase in price, increase in quantity. Again, no surprises here. When we do a decrease in demand, and it's going to shift to the left. P prime, Q prime. I don't want to buy so much of this thing anymore, so I'm not going to be willing to pay as much for it, and I'm going to buy less of it. If you're wondering how this works out algebraically, by the way that it works out is that I tell you what the new curve is, and then you just do the same two unknown things that we did before, just got the new curves.